My name is Patrick. I'm here to talk about the part 2 of measurement of specific capacity. Now this time around we are going to be talking about experimental determination of specific capacity of a liquid by the electrical method. Previous time we talked about solid by the electrical method. Before I start, please don't forget to like, share and subscribe on our YouTube channel at Scholars Card. Alright, now look at the board. Now we have an experiment. This is an experimental aspect of its capacity, specific capacity. Now this is a bowl. You can draw it. This is an aluminum bowl. Now this is an unknown liquid. What I mean by unknown liquid could be water or kerosene or oil. Are you getting it? An unknown liquid inside the bowl. Now you connect an electrical source inside the bowl and get a thermometer. Thermometer used to measure the temperature. Now we have a thermometer here, and I also have a felt jacket to prevent electrocution in case you maybe mistakenly touch the body. Are you getting it? Now also we have heater. This is the heater. Inside the heater, inside the bowl. Normally if you want to boil water, are you getting it? Without using gas. So you want to use the electrical, using your boiling ring. You inside the heater inside the bowl and you on your electricity, your socket. Are you with me? Now, first of all, you measure the initial mass of the bowl with a weighing balance. We call it chemical or beam balance. You measure the mass, the initial mass of the body of the bowl, which is M. Are you getting it? In kilogram. Also, now you measure the electrical energy. The electrical energy supply to the bowl when you on your socket. Are you getting the electrical energy supply? You can do that by connecting an ammeter. We use an ammeter to measure current. When you on it, you measure the current that will flow, the amount of current that will flow through the bowl of liquid. Are you getting? So you take it as electrical energy H here as IVT, current times the voltage times the time. Also record your time. You can record the time with a stopwatch or a stop clock. Now after that, you now pour the liquid inside the bowl. When you pour the liquid inside the bowl, now you measure it again. For you to know the mass of the liquid, you have to pour the liquid or non-liquid inside the bowl and reweigh it again. That which is M2. Let's look at M2. The second mass. Are you getting of the bowl? Now the next is of the liquid. The next is you have measured the mass of the liquid as M2. After then, you now measure the temperature. Also note the temperature. Measure the temperature by using the thermometer. We use the thermometer to measure temperature. The temperature, initial temperature of the water, of the liquid. Initial temperature, which is, you could target as θ1. Initial temperature, θ1, which is Kelvin. Are you getting it? Kelvin. Now when you measure the initial temperature, you now on the socket. After on the socket, you find out that you can gradually take your readings. Remember, water boils at 100 degrees Celsius. The moment you on your socket, you start taking notice, observation from the thermometer. So wherever the water start to boil, the liquid start to boil, you take it as a final temperature. We'll tag this one as θ2, final temperature. Are you getting it now? Yeah, we have two substances here. The liquid. The unknown liquid, that is the specific capacity of the liquid. Let's assume this is water. So we have the specific capacity of the liquid here. Specific capacity of the liquid. You have C to use C to indicate specific capacity of the liquid. Let me use L. Specific capacity of the liquid as joules per kilogram per Kelvin. Are you getting it? Of the liquid. Now also the specific capacity of the bowl, of the aluminum bowl. The specific capacity of the aluminum bowl. Okay, joules per kilogram per Kelvin. Are you getting it? Now, you measure all this one like this. Now, after that, you now take from the law of, we have a special law under this topic. We call it the law of mixture. The law of mixture. Now, the law of mixture states that the heat supply is equal to the heat gain. The heat supply equals to what? Heat gain. That is, heat supply by the electrical work done is equal to heat gain by the liquid and the aluminum bowl. Are you getting it? That is, is supplied by the electrical, which is energy, which is IVT, current IVT, current times potential difference, volt times the time, is equal to heat gain. Now we now talk about the heat gain here by the aluminum bowl and the liquid. Now heat gain by the aluminum, some of the heat gain by the aluminum bowl, which is M1, that is heat gain by the aluminum bowl. Then also the specific capacity of the aluminum bowl, the specific heat capacity C of the aluminum bowl. Are you getting that? Temperature of the aluminum bowl, initial temperature of the aluminum bowl, and the final temperature of the aluminum bowl, that's change in temperature, plus the liquid, the specific the mass of the liquid, which is M2, plus mass of the liquid, plus the mass of the liquid, are you getting it? Mass, which is M2, mass of the liquid, then the specific capacity of the liquid, and change in temperature of the liquid from final temperature to the initial temperature. Are you getting it now? This is the electrical method of measuring specific capacity of a liquid. Now note this. Sometimes they will ask you to neglect the heat capacity of the bowl because you can use a rubber bowl. Are you getting it? For instance, if you are using a plastic bowl, you might be asked to neglect the heat capacity of specific capacity of the bowl. Now, if you are doing that, which means you are also going to neglect the mass of the bowl. So you are only measuring the mass of the liquid. In that case, now you don't have only one mass, which is IVD, electrical energy supply, will be equals to mass of the liquid and specific capacity and change in temperature as temperature of the liquid. Yeah, you can make this one the subject of the formula as usual before. Are you getting that? C, that change in temperature, initial temperature of the liquid to the final temperature, that is C equals to electrical energy supply all over mass of the liquid times specific capacity of the liquid and change in that as θ2 minus θ1. So this is what electrical method of measuring specific capacity of a liquid. Don't forget, C stands for specific capacity. This θ1 stands for final temperature of the liquid, while this θ1 stands for initial temperature of the liquid. Final temperature of the liquid, θ2 minus initial temperature of the liquid, while this is stands for the specific capacity of the unknown liquid, and this is the mass of the liquid. While this one, IVT, current times volt times time, which is the electrical energy supply to the liquid. Are you getting it? God bless you. Don't forget to like, share, and subscribe on our YouTube channel at Scholars TV.